In this video, we'll look at the derivative of the natural log function. So the natural log function has a derivative. So if we say let y equal natural log of x, then the derivative of this function is 1 over x. So this will come back to be important when we talk about the integral in the next section, but for now this is all we really need. So just like before, the chain rule is certainly important, and so if you have something like this, so let's say that you take the natural log of some function, the derivative of that is 1 over the function times the derivative of the function. So the chain rule may still apply. Okay, so let's look at a specific function example of this. So let's let y equal natural log of the square root of x squared minus 8. Now I'm actually going to take the derivative of this function in two ways. In fact, why don't I write this up here? And then, so the first way that we're going to take the derivative of it is let's actually rewrite this just a smidge. Let's go ahead and rewrite this as that stuff to the 1/2 power. Okay, so one way that we could do this would be to say, all right, the derivative of the natural log of some stuff is 1 over that stuff, and that part you just copy down, times the derivative of the stuff. Okay, now we need to take the derivative of this stuff, and for that we can just use the power and chain rule. So this part will stay the same. And then here, the derivative of some stuff to the 1/2 is 1/2 stuff to the minus 1/2 times the derivative of the insides, which in this case is just 2x. And then we want to simplify this a little bit. So one thing to observe, of course, is that this 2 and that 2 cancel, so that's easy. The other thing to observe is that we can actually group together this part here and this term here, because this is to the 1/2 power in the denominator, and this negative exponent means that this is also to the 1/2 power in the denominator, and something to the 1/2 times something to the 1/2 is just the thing itself. Okay, so I could simplify that to get this form here, and this is of course much nicer than this form there. Okay, so that's it for that method. Now I'll show you a maybe a different way to approach this problem that would be a little bit cleaner. Oh, I'm sorry, we forgot the x from right here. Forgot that. Okay, so let's do this in a slightly different way. The first step here is, let me just rewrite the function. And you may have actually thought to do this when I rewrote the function like that, because you probably noticed, hey, this exponent, I can actually bring that out front of the logarithm. And so the function that we're dealing with is in fact the same as this function here. And so the derivative would be the same as if I took the derivative of this version of the function. And this one's a lot easier to deal with because there's no exponent anymore. So the derivative of that will be 1/2 times whatever the derivative of this log stuff is. And the derivative of log is 1 over the stuff times the derivative of the stuff. And if we cancel the 2's like we did before, we get x squared over x squared x over x squared minus 8. So we'll talk about this more in class, but one of the morals of the story here is if you can simplify, so we simplified by bringing this 1/2 out front using the law of logs, that log of a to the b is b log a. If you can use a rule of logarithms to simplify, it might be a good idea to do so, because notice that this was almost a joke compared to the kind of gymnastics we had to do over there.